Okay, so we're going to talk about, we're going to probably do the graphing piece tomorrow, okay? I'm just going to work with the basics today. We're going to talk about some vocabulary today, okay? It's going to do weird things on me. All right. So that's the picture of the sine curve, all right? When we do go to graph it tomorrow, we typically go from, we usually start at 0, and it makes, it always goes from -1 to 1 on the y's. That's where we start. When we talk about the period here in a few minutes, we typically do a 2 pi period, which means it's 1 revolution around the circle. If I kept going, because remember the unit circle keeps circling around, that's where we get the other waves from, okay? We can go backwards and go in the negative direction around the unit circle. So there's always a max and a midpoint within the period. And then there's usually 3 intercepts for the sine curve. And big thing, sine curve starts at 0. Cosine curve starts up at 1. Okay? It's kind of the same thing. And we draw some key points and then we fill in and are able to follow some patterns when we graph it. All right, go ahead and fill that in. All right, so when we go to graph it, the period is considered the cycle length of a curve, okay? When we graph it, we start with these key points within a period. So we start with the 3 intercepts, a max and a min for sine. For cosine, we have 2 intercepts and 2 maximums and 1 minimum, okay? All right, and then underneath that, that's kind of showing you a picture of where all the intercepts are. I tend to break it up like that when I graph it. We'll get more into that tomorrow when we actually do the graphing, okay? All right, then it should say something about amplitude. Does it say something about amplitude next? Maybe on the next page. Oh, there was a big box underneath, right? Cross out that box. We don't need it. I'm not going to mess with that box. I don't like it. Okay. All right. Let's look at amplitude. Okay. So, you have the amplitude is the height of the curve, okay? It comes from this letter A that's in front. And sometimes we don't always see the equation written that way. Sometimes they'll write the equation, just depends on who's writing the equation. Sometimes that D value will be in the back. So sometimes it'll be A plus sine of BX minus C plus D, okay? A is a scaling factor, so that means it's going to be do your vertical stretching and shrinking. The range is between negative A and A. All right. Did you have the box about amplitude? I know there's something else in between there. It talks about the way how it reflects. We'll do that here in a second. The amplitude is the absolute value of the A. So whether it's negative or positive, the amplitude, and we only count the amplitude between the x-axis and however high it is. Okay. Then it says something about the reflections, right? So the first one I think should be x-axis. And I'm not sure about the second one because when I put it in my calculator, it looked like it didn't change it. So let's just fill in the first one for x-axis. It's a reflection across the x. And then if we'll come back to it because it's talking about the A value. The B value, I'm not sure that it does anything really to it, that it doesn't really do a reflection, at least when I played with it here a second ago. Okay? All right, you have to fill in that box that talks about period. Okay, so this is basically the only formula we need to know for this section. In order to calculate the period, we take 2 pi and we divide it by that B value that's in there. Okay, so we're going to do that here in just a second. So we've got to find the period and the amplitude. I gave you the picture so you can count it, or we can use the function to do it. So if I were to just look at this and I was to count from here to here, I would count 1, 2, wouldn't I? So it has a height or an amplitude of 2, but I also see that that's the A value. So your amplitude is technically the absolute value of 2 or just 2. All right. What's the B value right now? It's just the 4, not the X. It's the number in front of the 4, or the front of the X. Okay, so B is 4. So to calculate my period, I do 2 pi over B. So 2 pi over 4. So what does that reduce to? Pi over 2. So that means that, and the period is basically where it repeats. So see how it goes up wave, down wave, and then it starts over? So that means from here to here, the measurement is pi over 2. Okay. All right, let's try the next one. All right, so your amplitude, let's do the amplitude first. What's the value that's in front for your A? -3, and I'm supposed to do a absolute value of it. So what's the absolute value of -3? 3. So your amplitude is 3. To get your period, we do 2 pi and divide by what? It's not 3 this time. Couldn't we rewrite that as 1/3 x? So what's the coefficient in front for your A? 1/3. Okay. So now I'm going to do my fancy algebra and multiply by the reciprocal. So what's the length of my period? 6 pi. Notice, look at the graph got scaled. You got to watch your scaling on your graph because we'll change it all the time on you. So basically for this one, it was a cosine, so it started low, it went high, and it went low again. Okay, so as long as you see that, and then the pattern would repeat from there. All right, period and amplitude on this one. Let's talk about amplitude first. Amplitude tends to be easier. Notice, did I give you a picture this time? No, we don't really need the picture because we can do it all from the function. So what is the amplitude? What's your A value? 1/4, it's already positive, right? So I could just write 1/4. The period is 2 pi over B. We're trying to trick you on this one. What's your B value this time? It's pi over 2. Because pi is a number, right? So it's whatever the number is in front of the x. So pi is going to get included into that. So you've got 2 pi times, I'm going to flip the reciprocal, 2 over pi. So what happens? Pi cancels, so how long is the period on this one? 4. Alright. Oh, there it is. Okay. If we look on the 4 there. I want you guys to try that one on your own. Find your period, find your amplitude. So everybody take a minute and try it. Alright, so for your amplitude, what number did we get? 1 over 3, right? We're hoping that's on the next test a lot, right? Okay, period. We would do, what goes on the top of the period formula? 2 pi, and then what's on the bottom for this one? 6 pi, so what's your period length? 1/3, okay? The ones that we're giving you here, they've got a lot, some of them have pi's in it. We don't tend to see that as much when I try to do the graphing. We try to keep it in terms of pi. Alright, remember when we had those blanks that were weird? I now know what they are supposed to say. Alright, so this, go back to that, the top of that page we were just working on. Okay? The top of that page we were just working on has those formulas, right? Okay. So go to the top of the page we were just doing the examples on. Okay, where the blanks were that I didn't know what the second one said. Alright, so the D value is going to be a vertical shift. Okay. The C value is a horizontal shift. So see, remember how we go in and out of parentheses? We change the sign. And that's the same thing. That goes with the X value. The one that's on the outside goes with the Y value. Alright. And then this is what should be in the two blanks. The reflection in the X-axis and the reflection in the Y-axis. The other blank should be a y-axis. It didn't seem like it moved to me when I did the negative in front, so I wasn't sure off the top of my head. You can see how much we use it if I don't know it, right? Okay, let's talk about this one. So we're supposed to describe the shifts between the graphs, and we're going to consider amplitudes, periods, and shifts, okay? So we're basically comparing the two graphs. Alright, so if I have a sign, that's my original and this is my new shift here. If we're talking about, if we go think about this, so remember inside's horizontal, outside's vertical. So am I going to go in the left-right direction or in the up-down direction? If I'm inside the parentheses. So inside the parentheses is left, right. Okay, horizontal. So in the horizontal direction, so we would say G is a shift of pi units, because we're adding pi. But remember when we come in or out of parentheses, what are we supposed to do to the sign? Change it, right? So it's really a negative pi. So it's pi units. Negative means we go to the left. Alright, let's talk about the next one here. Yours wasn't in parentheses? Oh, yours was different? Did yours do this? Your table was different? Yeah, I know that that was different. Where you had this was up at the top of the page, right? Alright, so yours was like that? Sorry, let's fix it to yours. Okay? So if G is a shift of pi units, if yours looks like that, what should it be doing? Should it be going left or right or up or down? Up, down. In this case, it's going to be pi units up. I wondered why it said that, because mine said that in my notes, but I didn't. I'm like, well, that's not what the PowerPoint's saying. All right, pi units up. All right, let's look at that one then. This one should, do they match on that one? Okay, awesome. All right. So it looks like we have, the only thing that's different is the negative sign, right? So the negative sign is a reflection, according to what we wrote down here. What is it a reflection in when B is negative? Y-axis. So we would say that G is a reflection in the Y-axis. All right, let's talk about the next one. What's different? What are the two things that are different? Negative and what? The 3, right? Okay, so and the 3 is going to do a kind of a shrink or a stretch, right? But we're going to talk about it be in the terms of amplitude for trig, okay? So let's start with the reflection. So G is a reflection. Which axis when it's in front? X or Y? X-axis. Okay, and so this is talking about the amplitude. We would say that it has 3 times the amplitude of the original. So has 3 times the amplitude. All right, we good with 7? Okay. Let's look at 8. So we're going to describe the relationship between the graphs again. So what's the big change in this one? The 1/2. And what's the 1/2 describing? It's the amplitude. So all we have to do is say that G is 1/2 the amplitude. Or 1/2 times the amplitude. All right, let's look at 9. All right, so on this one, what's the big difference? The +4. So with the +4, what's going on? Is that a left-right shift or an up-down shift? Up and down, right? Should it be going up or down? Up. So G is a shift up. All right, is that what your 10 looks like? Yeah? Okay. So we're supposed to describe the relationships between the graphs, and they gave us pictures this time. So it looks like the only real difference, they're both definitely the same curve. Looks like the only real difference is the amplitude, right? So count how tall that second amplitude is. What are we getting? 4. So all we have to do is say G has 4 times the amplitude of F. G has 4 times the amplitude of F. All right. Ready for the next one? All right. I'm assuming this says 11 on yours. Is that right?
Yeah.
Yeah? Okay. Mine's a little bit off. We've changed the PowerPoint a little bit, and I didn't change the numbering. Okay. So find A and D for the function. So this means that there was it looks like that there's a shift up and there's an amplitude change. Okay. So this one's a little bit, what I do to find the amplitude change is I tend to count, or to try to figure out how, tend to count what the distance is between the lowest and the highest. So count all your little marks in there for me. Okay. How many do we have? 8. So basically what we want to do is divide that number by 2 to get our amplitude. So we had 8 to start with. So if when I divide that by 2, what's the amplitude? 4. Okay. So I know that my amplitude is 4. I need to figure out how far it shifted up. So here's what I'm going to do. I'm going to draw another line in there like it was an axis, and that way we can kind of count the shift up. So I'm going to come down from here, and I'm going to go 1, 2, 3, 4. It's right about there. So that's what it would look like if the red line was my axis, right? So how many did it go up from the axis? 1, 2. It looks like it went up 2, right? So the distance, or the D value, is going to be 2. So it shifted up 2. All right, let's look at the next one. What is the distance between here and here? How many spaces? It looks like 1, doesn't it? Yeah, it's just 1. So if I'm looking at that as just 1 space, it's kind of halfway in between on the marks, right? So that means my amplitude is 1/2 this time, right? We divide that count by 2. Then I need to figure out, so if I'm going to divide that by 2, I'd kind of run a line right through that mark right there. So if that was my axis, where the axis would be, I would want to count from that axis, from my x-axis down, to see what the shift is. So I'm seeing 1, 2, 3, is it 4? But it's not just 4, it is -4 because it went in the down direction. All right, and then does that finish up? Oh, then it starts the graphing piece, right? Okay, we're gonna save the graphing piece for tomorrow because this one was example 12. All right, so the other thing I have on there for you, because you know, you guys it's always nice to see the real life example. Okay, so when I put this in a few years ago, this is one of the things that came out with Amplitude. So interesting in here, the amplitude and period are important in the study of music, acoustics. An amplitude indicates energy or loudness of a sound, and the period determines its pitch. Okay, so it does have bearing on our real everyday life, right? All right, the other thing, we live in California, right? We get a lot of earthquakes here, don't we? There's a, isn't that kind of look, the amplitude of the wave is the, how big the earthquake was, okay? So we see this particular, at least this particular graph quite a bit in our everyday life, okay? All right, I'm going to give you an assignment here. So actually it's posted in Haiku. So go ahead and go to Haiku. And I double checked, it leaves off all the graphing. Okay? So we'll do the graphing part tomorrow. Alright. So if you guys want to get out your notebooks and get started on that, that would be good. If you give me a few minutes, I will come around and stamp. Okay, so what we're going to start with is we're going to start with just graphing a basic sine and a basic cosine, and then we're going to do some amplitude changes and some shifting, okay? There's another thing that's called phase shifting. It's way, way complicated, and it's not something we really need for AP Calc, so I kind of skip over it. But just know that we can shift left and right and move the period in weird ways. But I choose not to do that because it's more trouble than it's worth. Okay. All right. So we're going to start with sine. We're going to include 2 full periods. So first of all, let's calculate the period for sine here. So remember, period is 2 pi divided by b. What's the b value in front of the x right now? 1. So my period length is 2 pi. So notice I've left, like looks like there's some blank pieces in there on the graph. That's for us to scale it ourselves. I did not put a scale on the graph, but I tend to scale them, and they all kind of end up looking like the same graph, even though they're different. So you really got to watch your scale on here. So I'm going to choose to make this length 2 pi, which makes this one out here negative 2 pi. So if I go from 0 to 2 pi, that would be one period, and from negative 2 pi to 0, that would be another period. Once I've drawn one period, I kind of follow a pattern, okay? All right, so halfway in between we discussed is going to be what? 1 pi, okay? So it's 6 marks out is 1 pi, because it was 12 marks total, right? And I'm going to give you some of these graph patches to do your assignment on tonight. All right, and then halfway in between that is pi over 2, and halfway in between that is 3 pi over 2. I'm not going to do the... I'm just going to put the marks over here. I'm not going to do the calculation on this on the left side. All right, so for sine, if all else fails, you could always do a t-chart, okay? But there's some basic things that we know. We know that the sine always starts at 0. Whereas the cosine starts at 1. Okay, so that's the big difference. What's the amplitude right now? What's the number in front of the sine? 1. So that's as high as it's going to go. Sine always goes into a max first and then a min. Okay, so that's the pattern I'm going to do. So I go up 1 to a max. It has to cross the x-axis again. So I'm going to do down to the x-axis, and then I'm going to go down 1 to a min, and then back up to the x-axis. So do you see the pattern I created? We're going to do that same pattern. I'm trying to do this as painless as possible, because a t-chart with trig would be kind of a pain, right? Trying to do that. We're just trying to follow a pattern to get it graphed. All right, so if this is up, where should it go from here? Should it go back up or should it go down? It's going to go down 1, and then the pattern is it has to go to 0, then it has to go up 1, and then back down to 0. And then I connect the dots in a smooth curve. So that wasn't so bad. Okay. So that's your basic sine. All right. The idea is get your scale on there first. Mark your 4 spots, okay, in between. I draw my scale on my graph first, and then I draw the graph. Okay. All right, so looking at cosine, let's calculate the period again. So period starts with 2 pi divided by b. What's b? 1. So your period is 2 pi. That's what I make. I make the length of my period here and out here. Okay, then I mark halfway in between, halfway in between, halfway in between. Then I'm going to mark here halfway in between, halfway in between, and halfway in between. Do I really need the numbers on there? Not really to draw the graph, right? They kind of almost get in the way. Okay. All right, so let's talk about the cosine pattern. What's the amplitude of this one? 1, because that's the number that's in front of the cosine. Does cosine start at 0 or at 1? 1. And it's starting up because it's positive. So we're going to go start at 1. And then it has to go, that's the max. So it's going to have to go down. And so we have to cross the next mark has to cross the x-axis. And then I'm going to go down to the -1 on the next mark. And then where should I go from here? Should I go up or down? You need to go back up to the x-axis, and then I go up to 1. And it should look curved, not like a V. Okay. All right, we're going to follow the same pattern over here. So from this point here at 0, where should I go? Should I go up or should I go down? Down. Where should I be? Where should my mark go? At 0 or -1? It has to go to 0 first. Then on the next dot it goes to -1. Where should it go from here? Back up to 0. Good. And then where should it go from there? Back up to 1. Good. Oops, I totally missed. Don't miss. I totally missed. That's better. Alright, so we've graphed the most basic sine and the most basic cosine. Those are the parent graphs that we just did. Okay? Alright, so let's talk about this one. Let's talk about the period first. So, let's see, I have 2 pi divided by, what's the b value right now? 1, so isn't my period just 2 pi again? Eventually we'll see a period change here, I'm sure. Okay. So I know I've got to go halfway in between, halfway in between, halfway in between. I'm going to make all those marks. Let you catch up with me. Because it makes it really easy to graph it. Okay? Because that's what the scale is, right? If this is 2 pi, I know that this is pi. I know that's pi over 2. I know that's 3 pi over 2. So I'm marking all the halfway points. Okay? All right. Where does sine start? At 0 or at 1? 0. Okay, height of 0 it starts at. All right, what's your amplitude this time? 2, right? Because that's the number that's in front of the sine. Which means my next mark, sine goes up first. So I'm going to go up to 2. So now where should I go from there? Should I go up or down? Down to 0, right? All right, and then from there, where should I go? Down to how far? -2, good. And then from there, where should I go? Up to 0, excellent. And if you want to sketch that half in, you can. Okay, so from this 0 point, do I need to go up or down? Down. How far down am I going to go? Good. From -2, where am I going to go? Up to 0. Excellent. From 0, where am I going to go? Up to 2. And then from 2, where am I going to go? Back down to 0. And it should look like the wave, right? But all the graphs should look like a wave today. Yeah, we shouldn't have sharks. They shouldn't look like shark fins, okay? They should be curvy. All right, we good with that one? Pretty easy so far, right? Probably almost easier than graphing a line. All right, looking at this one, remember this is the same thing as saying cosine of 1/2 x. That's how you got to look at that, okay? So let's talk about the period first before I do anything else. So what goes on the top of the period formula? 2 pi. What's your b value? 1/2. So I'm flipping and multiplying, so it looks like I have a period of 4 pi, which means this mark here, I'm going to scale it as 4 pi. Which is going to make it kind of look like our other graph, but the scale is different. What would halfway in between on 4 pi be? 2 pi. And what would halfway in between on that be? Pi. And again, these measurements, they're important, but we don't really need them to do the graph, unless I was doing a t-chart. I'm going to do the same thing over here. I'm going to put the scale of -4 pi there, and then I'm going to mark halfway in between, halfway in between, and halfway in between. All right. What's the amplitude?
1.
It's 1, right? Because my coefficient in front is a 1. So I'm going to be now does cosine start at 0 or at 1?
1.
Good. So does cosine go up first or down first? Down. And where I'm going to go down to 0. Then where do I go? So I was up at 1. I'm down at 0. Do I need to go up or down from there? Down to -1. Okay, from there, where do I go? Up to the 0 at 3 pi. Good. And then where do I go? Up to 1. Excellent. And if you want to start drawing the curve, the cosine is harder, I think, to get the curve. I don't know why. No, it's not. I'm trying. Leave the second line, not the first line. No shark fins. Okay. Why does it go down first? Okay, if you have to, do the t-chart, right? So you put in the pi value. What's the cosine of pi over 2? So this is the cosine of pi over 2, right? Isn't the cosine of pi over 2? Oh, no, it's 0, 1. Isn't it 0? So that's why it goes down first, because that's the coordinate it would come up with. I'm just skipping the t-chart. Okay? Showing you the pattern instead. Alright, rather than us, you know, using the t-chart, I'd rather us just graph by the pattern. Alright, so from here, should it go up or down for it to go to the left? Down, how far? 0. Okay, then from that point, where should it go? Down, how far? -1. Okay, then where? Up to 0. Okay, then where? Up to 1. So again, it should look like a curve, not like a shark fin. And I know it looks identical to our other cosine, right? But the big difference is this was at 4 pi instead of 2 pi. All right. We good with 16? Okay. Looking at this one here. All right, we've got a couple of things going on. So, let's first of all calculate our period. So our period is 2 pi divided by, what is the value in front here? Pi over 4. All right, so let's flip that and switch to multiplication. So what happens? The pi's cancel, and 2 times 4 is 8. So I know it's going to seem strange, but let's leave our scale at 8, which means halfway in between would be 4. So if I was doing a t-chart, these would be the numbers that we would be putting into our t-chart. What, 6? And then let's at least draw our marks. -8 there. Or halfway in between marks. All right, what's the amplitude this time? The amplitude is 1. We know what signs start at 0 or 1. 0. This is going to tell us which direction we go first. If it's positive on the sign, we're going to go up. If it's negative on the sign, where are we going to go? Down. Okay, so let's go down with this one. So I'm going to go down first. I know I'm only going down to -1 because my amplitude was 1. Okay, then from there, where should I go? Up to 4. At 0, right? As far as 0. Okay, then where do I go? Do I go up or down from there? Up as far as 1. And then where do I go from there? Back down to 8, right? At 0. Okay, and then I'm going to start drawing my curve. All right, so now let's keep following the pattern. From this point here, do I go up or do I go down? Up as far as 1. And then from that point, where do I go? Up or down? Down to where? 0 or -1? 0. Good. All right, and then from there, where do I go? 0 or up or down? Down to -1. And then from that point, where do I go? Up to 0. All right, so we're going to do that. All right, we good with 17? All right, looking at 18. So the big difference here, not only do I have, it looks like my period stays kind of normal, right? What's the period on this one? 2 pi, right? Because there's nothing in front of the x. It's a 1. What's your amplitude on this one? 1/2. Good. But it looks like it's shifting. Where is it going? Up or down? Down. Okay, so here's what I'm going to do. I'm going to sketch part of it on this right side here, and then I'm going to translate it down. Okay? So I know I'm scaling at 2 pi. I'm going to make all my halfway in between marks. So do that part. We know we can all do that part. All right, so does cosine start at 0 or at 1? 1, but in this case, should I be starting at 1? I'm only going to go high as 1/2, so I'm gonna put my dot up at 1/2. Let me use a different color. Okay, because my amplitude is only 1/2, so I'm only going to go up as far as 1/2. All right, so from there on cosine, do I go up or do I go down? down. Okay, so I'm going to go down to 0. And then from that dot, do I go up or do I go down? Down again to negative 1/2. So it's going to look squished. All right, from that point, do I go up or do I go down? What do we think? Up, okay, as far as 0. And then at 2 pi, do I go up or do I go down? Up to 1/2. I'm not going to sketch it. I'm going to just draw dots. Because this really isn't my true graph, right? Because I have not done this shift yet. I have to do the shift. So how many is it supposed to be shifted? Down 2. So I could count -2 down on each one of those points, couldn't I? So remember, every 1 down is a gap of 2 on the grid, right? So that would be 1, 2. So that would be where my first dot goes. And then I could count down 1, 2 from that dot. And then 1, 2 for this dot. 1. Where am I at? That's wrong. 2 right there. And then it should line up with this one right here, right? The key is getting half of it drawn, and then you're able to kind of translate it or draw the right or the left half. Okay, so let's see if we can, based on that, let's see if we can draw the left half. So where should this dot go? Should it go up or down? From this piece point right here, should I go up or down? Down. And I'm going to line it up with this other dot, right? I'm going to follow the pattern that I've already established. From that dot, should it go up or down? Down. If it helps you, this piece here is kind of like the axis, isn't it? If you want to draw that line in there so it acts like your axis and that helps you, that's okay. All right. All right. From this point, since it's below where the axis would be, should it go up or down? Up, back up to where the axis would be, right? And then from that point, should it go up or down? Up. And then sketch that one in. I think the translated ones are the hardest to do because you don't have that axis in there. All right, we good with example 18? All right, 19. Oh, I think this one needed to have... I think if we go up 2, we do too many. I think we need to change this to a 1. So is there a 1 on yours or a 2? 2, yeah, let's change it. I'm looking at my notes from last year, and if we go 2, we fall off the graph paper. So we don't want to do that. All right, so let's try by figuring out the period. So first of all, what's your period going to be? 2 pi divided by what? 2. So what the length of the period is? Pi. And as long as you write that scale on the graph, that covers you, right? It's kind of cheating. But so halfway in between would be pi over 2 this time, right? I'm drawing my marks, all my halfway points. All right, what's your amplitude this time? 3, right? Because absolute value of 3 is 3. All right, so does cosine start up or does it start down? Or so it start at 0 or at 1? 1, but really it starts at 3 because of the amplitude. Okay. From there, does cosine go up first or down first? Down first. So I'm going to go down here. And then it should go down again as far as what? -3. Good. All right, and then from there, it should go where? Up to 0, and then back up to 3. And again, I have a shift, so all that I would do with this one is kind of dash it in there, right? Before I try to draw the whole thing. All right, let's look at the shift. How much am I supposed to shift? 1, which is 2 spaces, right? So I'm going to go up 2 spaces on each one of these dots. And I'm going to sketch that curve, making sure I'm curving it, not shark finning it. Yeah.
How come in example 18 where you have to shift it down 2? It looks like you shift it down 2.
Because each could look back up there. Oh, sorry. The shift looks like it's down 4, but look at the scale on the graph. Every 2 spaces is 1, counts as 1. Does that make sense?
Yeah.
So this is only 1, and this is 2. That would be 2. Even though it looks like on the grid, I shifted it 4 down on the grid, but the grid with each mark only counted as a half. Okay, does that make sense? Scale, super important, right? And if I left the squishy graph, then we lose all, because if I do an amplitude of 1/2, then it becomes trickier. So that's why I leave that extra mark in there, okay, on our grid. All right, so from this point here, where should I go? Up or down? Down. And I'm going to line it up with that point right there, right? Symmetry, it's all about the symmetry, isn't it? So from this point, where should I go? Up or down? Down. So I see this point right here. It should go as far down as that one is. I'm going to line it up with that point. From this point, should it go up or down? Back up, and I'm going to line it up with the point that's on the same horizontal there. And then from there, should it go up or down? Back up. And we're going to make it again look like curves, not shark fins. All right. Are we good? I think that's the last one, isn't it? Okay. So here's what I'm going to do. I'm going to give you some graph paper. You can get this glued into your homework notebook. I'm going to give you a big piece and a little piece. Okay? Because I think you have 10 graphs to do. All right, for the homework. So good on haiku. Find the homework worksheet.